Okay, good morning, everybody. Just checking. It's just after 8. Hopefully you've all got your coffee for those of you who are here, and for those of you online, well, I don't know, but you can slip out and get a coffee anytime you want, I guess. Welcome to our breakfast series. It's great to see so many people in the room. I wasn't 100% sure because for those of you who are not here, we've been getting warnings of nasty weather coming, but it's actually quite nice outside right now, so all good. And so I hope for those of you who are in the room that you'll stick around for some networking afterwards and say hello to everybody, and it's nice to see you. And I guess I can still say Happy New Year because it's the first time I've seen you. So my name's Alison Symington. I sit on the board of LSO, and I'm involved in organizing these breakfast meetings, and I'm really excited about this one. I've been working with some of these people, and so it's quite an exciting day to have them talk to you. So I hope you'll enjoy it as well. Just waiting for the technology. This is a deep technology breakfast, so we're hoping it's all going to work out. Okay. So before we get started, I'd like to do our land acknowledgement today. So today we recognize the land we're standing on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat people, and is now home to many diverse First Nations, Inuit, Métis peoples. I'd like to acknowledge that Toronto is covered by Treaty 13, signed with the Mississaugas of the Credit, and the Williams Treaty, signed with multiple Mississaugas and Chippewa bands. And I encourage you, wherever you are, to think about the land that you're sitting on and what your path will be in learning and as we work towards truth and reconciliation. I'd like to thank our sponsor today, RSM, and we're in their building today. What a lovely building. I haven't been in here before. And I'd just like to introduce Danny to come up and say a few words.
Thank you. Welcome to LSO's breakfast meeting, January 2023. We're pleased to be here and pleased to be a sponsor. My name is Danny Ladisser. I'm a partner at RSM, and I'm the life sciences industry leader for Canada. RSM is a full-service tax, assurance, and consulting firm serving the middle market, focus on the middle market specifically. We are in Canada 1,000 professionals in 6 offices, and on a combined basis with in North America with the US, we have 14,000 professionals, of which 800 are focused on life sciences. So we help our clients with a number of services. Life sciences companies, we help them with ERP implementation, digital transformation, cybersecurity, gross to net, strategic pricing, government funding, M&A, and IPO advisory. So, we've never faced such challenging times. We went through the pandemic together. We're now facing high inflation, economic uncertainty, labor shortages, and supply chain disruptions. And I think, at RSM, we love helping our clients face those complex issues and turn them into opportunities. So today, I hope you enjoy the session, and I look forward to meeting as many of you as possible during the following networking component of today's breakfast meeting. Thank you.
Thank you very much, Danny. I have to remember not to wander too far, so I'm going to get in trouble for wandering off the camera. So I'd also like to introduce to you Andrea to say a few words on the Life Science Talent Accelerator Program. Do I need to push it? No, I've already got it turned on.
Okay, perfect. Hello, I'm Andrea Moretson, and I'm here today to talk to you about a training program that we're developing in partnership with Life Sciences Ontario. So the Life Sciences Talent Accelerator is an industry-ready training program that we are developing, and it's being funded by the Ministry of College and Universities. So the intention of the training program is to give people entering the sector an introduction to the life sciences industry The program is industry agnostic, and anybody that might be fresh out of university or looking in to do a career change, we invite them to taking our training program. Obviously, because the pilot is being funded through the ministry, we do have some restrictions, but after March 31st, anybody could apply. So for this pilot, as I have there right now, we're offering $5,000 for a wage subsidy for life sciences companies that would like to have their new talent to take our training program and provide us with some feedback. So there is some eligibility there, but please, if you're interested and you're part of a Ontario-based company, please reach out to us. So our email is there at the bottom, and I welcome everybody to send me an email with any questions that you might have about the training program. And this is something that we're very excited to launch. And I forgot to say that the training program and the development of the training program is being led by BioTalent Canada. So if you have any questions, you can come and talk to me at the end of the session today, or you can reach out to me over email. Thank you.
So thank you very much. So now on to our larger part of the program. So that's right. I truly believe, and I've been talking about this with people for a long time, that true innovation happens at the convergence of technologies. And one of the ways that innovation happens is at the convergence of technologies. And I was very lucky to be able to work with some of the people with a really cool project that they're going to talk about and what their philosophy on this is. And then we'll listen to another group who are here, and you'll actually get to see some of the things that are going on. So the first group we're going to talk to are three very exciting gentlemen up there on the screen. You can see because they are coming from Quebec and from Switzerland, I believe, actually. And so obviously didn't travel down, and given the weather we're having, that's good. And they're going to talk today on Gamers for Science and how to change the world in small steps. And I would just ask you, we'll do questions at the end of each presentation. If you're going to ask a question online, please put it in the question and answer section, and we'll look for that. And if you're going to do a question here, we have these little mics. I'm just going to turn mine around. So you just press the button, it goes green, and then you can speak into it, because then everybody online can hear from you. So three speakers today. The first set are Attila, Jérôme, and Sebastien, and they'll explain who they are and what their companies do as they do their presentation. So I'll send it to, is it Attila's going first?
Yeah.
Yes, okay, so I'll let you go.
Thanks a lot for having us. It's three of us, so we have to be rather quick. My role in this presentation is to give you a general overview about the work we have been doing for the last couple of years. We're working in two major fields. One is video games and the other is science. So I'll start with video games. And my slides are not moving. Yeah. So if statistics tells anything, apart from you all in the audience, apart from being scientists, at least, or roughly 50% of you are gamers as well. So you probably know what GG, good game, means. I think what I want to emphasize here when we're talking about games is that we still battle that or fight that misperception of games. Many people still think that games are some kind of nerdy pastime, which cannot be further from the truth. And this misperception is very dangerous because I think it prevents a lot of very interesting, fruitful collaborations between academia or academic research or research in general and the game industry. And I believe that's super important, and games are becoming mainstream. There are 3 billion players around the world. The diversity of the player communities is because of these numbers are as diverse as society itself. And games are becoming one of the primary virtual spaces that we inhabit. So to be able to work together, I think we have to change this perception. The other leg of our project is science, more specifically citizen science, which is the involvement of the general public in the scientific process, which is a beautiful and very important tool in the scientist's tool belt, but unfortunately it struggles with engagement problems. And so that's where we came into the picture. Our small Swiss company, Massively Multiplayer Online Science, proposed, why don't we get these two worlds together and take citizen science and put them into major video games as an integrated part of the games to solve this engagement problem, because games are known to be very, very, very engaging. And so 8 years ago, we started to work on this. The first project that we set up was together with an Icelandic company, CCP, who were creating EVE Online. And in EVE Online, we created several mini games. One of them, this was the first one in collaboration together with the Human Protein Atlas in Sweden, when we invited players to analyze microscopy images of human cells. Later in 2017, we introduced a new project in collaboration with the University of Geneva to hunt for new exoplanets, which also involved the active participation of Nobel laureate Michel Mayor, who discovered the first exoplanet. And then in 2020, we introduced another project, data coming from flow cytometry, where we invited players to analyze this high-dimensional database by solving these clustering problems and trying to push forward the efforts to better understand how we can combat COVID. These projects became really successful. We got amazing press coverage. We get achievements like being on the front page of Nature Biotechnology, and also got really, really high profile awards for the project. And then in parallel with that, and that is going to be the main focus of our presentation today, I started a conversation with Randy Pitchford, who is the founder and president of Gearbox. And one of their main games is Borderlands, where we also started to discuss the possibility to setting up such a collaboration, which came to fruition in 2020, when in 2020 April, we launched Borderlands Science in the format of a super cool arcade machine inside the game. And in this arcade machine, you found a new minigame, sort of like an 8-bit retro-styled Tetris, Candy Crush-like minigame. But in the background, when you were playing with the tiles of this minigame, you were actually manipulating DNA information that was coming from the human microbiome. Now, Jérôme and Seb will go much more into detail. There's one story that I want to tell you about this, kind of to inspire you and try to showcase how substantial these collaborations are. With this project, how it started out is we based it on an existing citizen science project, which was funded by Jérôme, Philo, which existed for many, many years. And what happened is Gearbox game designers took this original citizen science minigame and transformed it into something which is more fun, much more fitting to the aesthetic universe of Borderlands. And then we launched it inside Borderlands 3. Now that day, that single day when we launched this minigame inside Borderlands 3, we collected 5 times more data than during the 10 years where Jérôme was running this project previously. This is the kind of power that gamer communities and game developers can bring to science. And on that note, I pass it on to you, Seb, I guess.
I think actually it goes to Jérôme.
Actually, to me, exactly. Yep. Thanks, Attila. Actually, it's a nice transition here, because so my name is Jérôme Waldispühl, and I'm the scientist at the table here, who's basically in charge and take responsibilities for all the science behind this project. So perhaps I think the Borderlands Science project, as you introduced, Attila, will probably be more explained by Seb. So probably try to bring more the story about the motivation, the scientific motivation of the work we've been doing. And so I'm a bioinformatician, and I've been working a lot on the protein RNA structure prediction, but also as all bioinformatician on comparative genomics, where the goal we have, one of the core problems that we will have, as you may know, is really to compare the DNA we get from different organisms and better understanding the similarities and the structure of this one. And comparative genomics is one of the most fundamental tools that we have in almost any biological research It has been the case for the last 30 years, and will probably be the case for the next 30 years as well. So the development of technology to make it efficient is critical to the development of the field. So typically the way it works is that we have algorithms to do that, but they're not perfect. So there's always a human eye going behind, try to correct the mistake of the algorithm. But the problem is, like, obviously it's not scalable. So the idea that we got there was, as Attila was mentioning, was about 10 years ago. I mean, more than 10 years ago now, unfortunately. We had to, we came with this idea of trying to engage the public or the web user into helping us to improve upon the alignment provided by algorithm of the DNA sequence alignments. And it was done by a game called Philo that we launched in 2010 at McGill. And it was just a small project, basically, we've done with some students that we did during the summer, and we posted it in the online after the end of the internship, and turned out to be one of the biggest success in my career. The principle of Philo was the following: it's like it's a way to improve upon computers, and what I'm saying here just makes even more sense now that we have the development of AI and ML technologies. I won't have to expand on that, but it's even more relevant here. But the idea is that we won't ask, of course, players to align the 3 billion characters of human genomes and compare it to the genomes of other species. What we're doing is, like, first we're using algorithm to pre-compute the data. We extract a small part, small chunk that should be recognized by human, and we send it to the game Philo, and after reinsert the result. Of course, this type of reinsertion is a bit tricky, but the big picture is there. So Philo was working for 3 main reasons. First, it's a fundamental problem in biology that's applicable to almost any field, in structural biology, in evolution, and so on and so forth. The second thing is, like, well, it's proven to be difficult for computers for many reasons. The first one is a NP-hard problem. It would take very long to compute an optimal solution. But the worst is, like, we even don't have a good scoring function to tell us when we're good or wrong. So we really need the human expertise to bring at a table here to be able to make to compute accurate alignment. And the last part that was the pillar of this work was really that how do we engage people? And we chose to make the first game that was really that had this casual aspect. We want a casual game that can engage everyone. You don't need to be a computer scientist. You don't need to be a bioinformatician. You don't need to have knowledge in biology. If you know how to play, you can contribute. And that was a message that we send out and we implement with Philo. So Philo was successful. We had, I think, over the 12 years now, we estimate about 700,000 participants. We solved 1 million puzzle, and we have very good, we have a demonstrated performances at improving alignment. And so the project worked very well, but the problem is, like, what we really want to do is to address much bigger societal challenges, and we have much more data to process. So even though arguably Philo was one of the most successful citizen science game in the market, it was very far to reach the power it needed to be effective at scale and to be able to process the data. Why? Because our goal is to address the challenge we have nowadays. And in particular, we have a partnership and for a long time with the MicroZeta initiative led by Rod Knight and University of San Diego, which is the largest catalog of DNA samples and provide basically all the data needed to power the microbiome research. But here we're speaking about very total different scale that we're doing with Philo when we're discussing about the genomes. We have 1 million sequences from different microbes, and we need to compare them. It was not possible with Philo. And this is why we need to reach out to the place where people are really playing. We cannot have a small website led by a scientist and wait millions of people to play a game. We need to have more people, and we need more engagement for people. So what people are playing? Well, they're playing games like Borderlands 3. And Borderlands, for those who don't know, is one of the most successful game franchise of all time. And this is what people are playing. When my students come to see me, they don't know Philo, but they know Borderlands 3. And the idea was that was brought up by Attila and MMOS was to merge Philo into Borderlands. And So the question now was how to bring Philo and make it possible to bring in borderlands 3. And I think this is what Seb will show to us and show the impact that this integration had.
Thank you, Jérôme. Thank you, Attila. I'll be sharing screen. So my name is Sebastien Caisse. I am studio head of Gearbox Studio Quebec and Gearbox Studio Montreal. We're a AAA video game developer, which means we make big games. And you can think of Montreal and Quebec here as 2 floors of a single studio. Everybody can hear me fine? Excellent. All right. So like the guy said, we're looking to merge the scientific endeavor with the wide reach that we can have through games. And what we're trying to do at Gearbox is really entertain the world, and the sustainability part here shines with Borderlands Science. So the key here is entertain. It's got to be entertaining for the players. And so we took Philo and merge it with a metaphor, if you will, within the game. Please realize that in the game, you're a character running around with your gun. This is first-person view, so you see your hands, you see your arms, you don't see your own character, and you're shooting around enemies and you're looting stuff. And so we thought, okay, how does that go with tile matching mechanics? And so the idea of having a place within the game where you can pull up to a virtual arcade booth is what became Borderlands Science. So we're taking the same tile matching core gameplay mechanic that Jérôme's team had created at McGill University. There's 4 different types of tiles, which represents the nucleotides. And what you see here, the little yellow bricks, push up other tiles, and essentially what you're doing is trying to match the pattern that is on the left side. And this is the sequencing that you're doing as a player. Now, you're going to be doing this because usually there's 2 parts of it. The first part of it is there's an explainer video that you can find on YouTube, by the way, by typing Borderlands Science. And this explainer videos explains to the player, okay, what is this? And so we're engaging them in this small mini game within the wider game by telling them this is citizen science and here is what you're going to be doing. So there's a why that is societal in impact. You know, we're going to be able to tackle things that have to do with obesity, neurological diseases, and so on. The other why is that as you play, you collect in-game currency, and so you can boost some effects that you have. Maybe your gun shoots faster, shoots longer, does more damage, and so on. So for the players, we're engaging them on both sides, the immediate and the long-term goal. And by the way, when we did the first tests, the one thing that came through was really the positive impact that the players were having by doing this. The fact that they were engaging in the citizen science minigame was its own reward. Of course, they won't say no to these things and the special skins and so on, but it is a good thing to let them know what they are doing. So I'm going to take you really quickly, step by step, on who's who and how it works. American Gut sends filtered sequencing data to McGill University. They send the alignment puzzles to MMOS. MMOS sends the ranked puzzle to us. We're sending back the players essentially by playing, solve the puzzle. So step 4 is puzzle solutions, goes back to MMOS. Step 5, package puzzle solutions, go to McGill, and McGill is able to provide improved alignments in step 6. Through all of this, there's also the opportunity to learn from what the players are doing. I think Jérôme mentioned it a little bit. Basically, we're trying to teach the algorithm to get better at what it does. So we launched this minigame as a free upgrade to everybody who already had Borderlands 3 on April 7, 2020. In the first 24 hours, we had more than 6 million puzzles completed, more than 150,000 active players. What I'm saying here essentially is that Attila's vision was right. It worked. By putting this scientific endeavor in front of players, it was a match. People engaged, and we had these incredible numbers that as of today, we've got more than 3.6 million active players in Borderlands Science. We've got over 125 million puzzles completed. We've had worldwide coverage in this. We had a nice article in Nature Biotech, Citizen Science, which I invite you to read if you have the time. And what we did here is interesting because it's versatile. That type of data can be used not only for the Microsetta initiative, but the same gameplay mechanic and the same type of metaphor we can reuse and present new research projects to the players. And if we were to develop a new game mechanic that is not about genomics, then you open up another field with all its diverse research agendas again. So I think I want to leave you with the thought that there's a lot of opportunity there. One of the key challenges is really engaging the dialogue at the researcher level and the game designers, so that when we design, we understand what is conducive to good science on the part of the research community, and the research community can think about, okay, what am I dealing with that can be gamified or as a core mechanic? So this is I would call it a new field at this point, and we're learning as we go along. And that's it for me.
Okay, thank you very much. That was absolutely fascinating. Are there some questions from the room? Well, while people are thinking of their questions, maybe I have a couple. And maybe first one is for you, Sebastien. So, you know, Attila and Jérôme clearly have got that science bent, and I think you do too. But for Gearbox themselves, what are the advantages for Gearbox to be involved in such an activity?
So in our case, so Gearbox, when the project started, was still a private company in the hands of Randy Pitchford. And Randy's a visionary guy, and he wanted to do good. He still wants to do good, and it's the same for us. When we became aware of this potential to do citizen science and AAA games, turned around to our team and had a show of hands of who wanted to participate in. So this is very much driven by the passion of the workers involved. And what I think we get out of it is, as craftsmen, we love to entertain people, but it is great to think that our craft can also lead to making the world actually better, that we can engage at other levels in society. And it makes for a group of developers that find, I think, more meaning in what they do. And it's also attracts that type of developers. In many ways, I feel this is a project that makes us stand apart from many others and is an identity factor of who we are at Gearbox. This is true of CCP Games also in Reykjavik. I think we're a peer group where we want to do leverage our craft to do more than simply entertain. We want to up our game.
Yeah, well, thank you. And to me, anyway, and I could see people's faces while we're talking, the numbers are quite staggering, actually. And so, and I think you spoke to this a little bit, so maybe Jérôme or Attila, were you shocked when the first data started rolling in and you realized how successful it's really going to be? I mean, Jérôme, you already ran a game that was pretty successful given where it was sitting on the web and everything, but were you really surprised about what a great impact it could have?
Yeah, I mean, I can tell you that it's, I remember first we had a lot of doubt, but when we launched it, because remember, we launched it on April 7, 2020. It was just the beginning of the pandemic. We had no idea what was in front of us. We know exactly if it was a good time to launch, but Gearbox decided, okay, it's a time to launch it. Let's do it now. And we had a lot of event planned to launch it. And finally, we did it from home, remotely. But it was an interesting time because we're all sitting there with a glass, discussing and chatting. And we were looking at this interface from that Attila and his team set up with the numbers that were growing and growing. And it's basically in a couple of hours, I was seeing that thing that we've done, it took us 10 years to do, basically being done just by chatting and discussing. And the numbers were not stopping and was accelerating all the time. So it's still, even though it was a tough time for you, mate, it was a very good time for me because we're discussing with friends and seeing this thing happening. And the engagement was nothing to compare with. Attila maybe had better thing to compare because he ran before the project discovery with CCP and had a bit more experience. But my experience with Philo was just like I see orders of magnitude improvement compared to what done before. And I see the vision that with Philo couldn't be done because we didn't have this engagement. And now I know that it can be done. And I know that we can build upon that to build successful initiatives to build better human-computer system for bioinformatics.
Yeah, it's really interesting because the launch of Borderlands Borderlands Science was really mind-blowing. I think all of us was amazed by the activity of players. I have also another really nice story from the very first project with Eve. So as Seb mentioned, a core part of the idea is this integration with the reward loop. So we're basing it on intrinsic motivation. We know that players want to help and want to advance science, but we also sort of say thank you for their effort with in-game goodies and rewards and boosters. And so in the first mini game with EVE Online, they created the ultimate reward, which was the EVE Sisters of EVE combat suit, a super cool looking suit for your character in game. And of course, game designers made some estimation of how much time it will take for the most active players to unlock this reward. And they were calculating with something like 3 to 4 weeks. The first one was unlocked 17 hours after launch, and the second one a shy 6 minutes later. So that's my warning that this is something really crazy going on here.
That's great. Thank you. I think we have one question from the room. Yeah, go ahead. Oh, here, you can use mine.
Sure, thank you.
Hey, good morning. Matt Switzer from Toronto Global. This is really, really cool. I'm interested in when you have the players engage with the game, inside the game, how do you tell them exactly how they're contributing? Is there a disclaimer? Do you need a disclaimer? I understand that they're going to get rewards, but how do they really understand the science and how they're contributing? And are there follow-along pages where they can really dive into that deeper? I'm really interested in that. And then I guess my second question on that is, once they figured out that science can be fun, has there been, I mean, have they been knocking down the door saying, more please? Can we add this? Can we add that? Just interested in that. Thank you.
That's a great question. Who would like to take that first? Sebastien, maybe?
Yeah, let me take the first part and I'll pass it on to Attila and Jérôme. So that's a great question. I think the key there is really the explainer video that's at the start. We worked with Mayim Bialik, who's a well-known actress and scientist in the US. And so that explainer video does a lot to explain what the project is. We've had more than 4 million players look at the video. And as you saw, we've got 3.6 million. So basically 90% of the players who look at the video start engaging with the game. So it's a really efficient way to go in. And I think after that, it's really, you've opened the door, however slightly, to the start of scientific literacy for some people, maybe. We get them engaged, and others may already be scientists. What I'm saying is you're trying to inspire people with this. So the next step is, okay, how do they get to know more? If they are really interested, can they dig deeper? And actually the answer to that is yes. And I'm going to pass on to Jérôme, who has a blog detailing what's going on.
Yeah, thanks. So indeed, I think it's a multi-layered strategy. We first have to attract the attention of the user and stimulate the curiosity, which is basically what the game is doing here. And as Seb mentioned, is one that there are many people wants to know more. So we developed this blog on dnapuzzle.org when we're explaining what we're doing in lay terms and giving update about what we're doing. And basically that was served as a base to basically provide more information. And some people inspired by this after contact us directly, we answer to them. So that's a much more communication that is done and at different level, depending on the person that is playing and the level of engagement and the knowledge they want to acquire. So currently, I mean, actually, I would say that the blog has been down for several months because we have the first publication that are getting out. So we're preparing a new series of publication and try to build upon that, because before it was not the result, it was mostly explaining what we're doing. Now we're moving into the phase where explaining the result we got from this, which is very important. But I would say also as a scientist, it opens a lot of opportunity to speak about our science. And maybe Attila can discuss a bit about this, because even if there's a blog and this, we have also many opportunities to go to channel and discussing, having panels and discussing directly with the communities. And I think that's also a real game changer in the way we communicate science and reach others.
Thanks, Jérôme. Attila, I'm going to have to cut you off, I'm afraid, because I do want to get to our other. But I think that's a really important point, and one of the reasons I wanted them also to speak to all of you, that these opportunities to look for convergence, talk to different people outside of the people you might talk to all day, really as scientists or as companies, really opens up other opportunities for you. I really want to thank you. I think everybody was absolutely fascinated. Maybe you'll see a little bump in people playing the game from here. And so thank you very much, guys. Appreciate it. So now I'd like to introduce Ben from SilicoLabs, and he'll explain what they're going to talk about today. This is a really, really cool company from Toronto that I had the opportunity to meet just recently, and they'll tell you all about what they're doing with some of their augmented reality.
A PhD candidate at the University of Toronto, where I do cognitive neuroscience research. And so when I started my PhD in 2017, a long time ago. Oh, that's better. I forgot. I told you I was going to forget. I was really interested in studying how humans learn and remember things in real-world environments. So a lot of psychology research, I don't know if anyone's had the experience of being able to do one of these tasks, but typically you go into a lab, they'll sit you in front of a computer. Sometimes they'll put you in an MRI, or they'll strap your head down so they can capture your eye movements and stuff. But usually they bombard you with picture after picture after picture. And then maybe at the end of it, they'll ask you questions about, what you remember in that experience. And so whenever you go to these psychology talks, you'll hear people say, oh yeah, we're really interested in learning how does somebody, associate these two things in the world. And so the way that we studied this was by showing them 10,000 pictures and asking them questions at the end. So very abstracted away from, what we actually do in the real world. And so when I started my PhD, there's typically the studies that got a lot of publicity are those that are real world type studies using, emerging technology. So naively coming in, I thought, oh, there must be a lot of really great tools out there already for creating these types of tasks or creating these types of experiments. But I quickly learned that that wasn't the case. And typically the labs that are doing this type of research are very well-funded labs. They have a lot of money, and they hire out development teams so that they can actually, the PhD student kind of comes up with the idea, and then they pass it off to a computer scientist who can actually create those types of tasks. I didn't have that type of funding. I was working with a new PI that didn't, have that type of funding. So I still, we were trying to essentially create a task where we could replicate what mice were doing. So what you might not know is that a lot of what we know about the human brain actually comes from rodent research. So we're actually able to, see what cells are firing in a rodent brain as they move around. We can actually capture that type of data with sensors that we can implant into their brain. And the type of tasks that mice can do is wildly different than the types of tasks we do with humans. With mice, we can't ask them about what they remember. We have to teach them where things are in different locations. And then later on, we might manipulate the experiment and see how one manipulation changes how they remember where that location is based on another manipulation. And so all we really wanted to do was create a really basic task where we were taking the real world kind of environment where we were teaching mice where specific locations were, and we wanted to emulate that for human participants. So with very basic kind of task, and getting that task up and running, creating the virtual space that kind of emulates that and putting it onto a desktop. That took me 2 years to go from start to finish, because not only are you creating kind of like this video game environment, this 3D environment, but what we're really interested in is all the behavioral data. We want to be able to capture, where is somebody going, and then we can actually use that data, which is a lot richer than what you would get from, presenting people images on a screen and maybe having them, press a single button. We can actually see how people move and walk through that environment. Yes. And so my first study was, a desktop study where we had participants come in and they were using the arrow keys to move around the environment and learn where specific things were in that environment. But, over the past, I would say 5 years or since I started my PhD, the technology, VR technology and augmented reality technology has just become, it's come so far. And it's not only cool that we can, replicate real world type situations, but it actually allows us to capture really rich data. So instead of just capturing, what button did somebody respond to and how fast do they respond to an image on a screen, we can actually put them into a real world environment, not only have them do something that is lifelike, but also capture all of that data as they're doing it. So we can see where they're looking at the environment with eye tracking that's built into these new devices. We can actually capture their facial expressions, so we can get at, if there's any sort of emotional response when somebody's, experiencing different types of stimuli. So even if you do want to present, images on a screen, now you're able to present those images on the screen in VR and capture much richer data than just button presses. And now with the new devices as well, they actually capture, your entire body movement as well. And so, this 3D technology and VR technology, it has, huge potential to revolutionize huge parts of healthcare. And so, for faster diagnosis, one of the best examples I think I have is with Alzheimer's disease, we have really good interventions that we can have people do that will prolong that process of the disease. The problem is with that is that you need to be able to catch that faster. And so the typical way that we're doing that right now is with tests like the MoCA and pen and paper type tasks. And they don't have a lot of high predictability, and it's much further along in the process that they actually become relevant to be able to catch, to identify that somebody is likely to develop Alzheimer's disease. There's a lot of really awesome research that's coming out right now where we can actually have people do spatial navigation tasks. So the part of the brain that starts to decay in Alzheimer's disease is called the hippocampus, and that's involved in your episodic memory, how you remember things, but it's also involved in being able to navigate the world around you and create kind of spatial maps of your environment. And so when we put people into an environment where we ask them to remember specific locations in that environment, we can actually pick up on, the minutia of how they, traverse that environment and how well they remember where those things are. And through that data, we can actually predict mild cognitive impairment with higher predictability. And we can predict Alzheimer's because of that sooner. So now all of these great interventions that we have, we can actually get to people and we can actually help those folks. also facilitates learning. I'm not going to talk too much about this because we're going to have a demo where Kyla's going to come up and show where we're actually, we can also use these types of environments for training folks. So instead of, bringing people into real world situations and having to train them, we can actually do that virtually. And then to fill shortages. So one of the really cool things that we've developed with the software is not only can you create these experiments or tasks, essentially video games like you'll see, but not only can humans do them, but we've actually enabled AI to do this as well. So what we can do is we can send out data to an AI model. Probably the best example is what we're doing at McGill is we're actually taking the pixel data that's on the screen on every refresh rate, and we're passing that out to reinforcement or an AI model. That AI model can take that pixel data, and then based on that pixel data and the prior pixel data that came before it, it can actually choose what action to take in the environment. It can then send back that action to the environment. And now we've essentially, created AI that do the exact same thing as what we're doing when we're playing video games. We're looking at the screen, and based on what's on the screen and what we know about the environment, we're going to pick which way we're going to go. We can now have AI do that same thing. And that's really powerful, not only because we can compare how well our AI model compares to the human behavioral model, but we can also capture all this really rich human data that can be used to train new AI models to behave more human-like. Just gonna grab a little water. So yeah, I think I've already talked about this a little bit, but these endeavors to create these types of tasks for researchers, psychology, neuroscience, cognitive neuroscience researchers, AI probably the exception, but we don't come from coding backgrounds. We don't do computer science undergraduate degrees. We typically do psychology degrees and more basic science degrees. So being able to leverage this technology is very, very difficult. And like I said, it does still require huge development teams. So yeah, this is where SilicoLabs comes in. What we have been kind of working on building is a software content. You can think about it as a content creation platform where you can create interactive experiences without having to know how to code and without having any prior experience with any of these like game development engines and stuff like that. The really cool thing is these experiences that you create, not only can AI and humans do them, but they can actually be exported to any device that you want. So you can do it on a desktop computer. You can export it to a mobile device. We have augmented reality, which is you can kind of put digital objects into the real world, and then virtual reality, where you're actually in a virtual world with other virtual objects. Oh, and so yeah, the software has been pretty successful so far. It's allowed researchers at U of T to continue doing online research during COVID. So we have a pipeline for delivering these online, putting them onto a website and sending out that code to participants. The second example on the slide, you'll see we have somebody hooked up to the Microsoft HoloLens and a mobile EEG sensor. So what our software allows is allowing researchers at Cambridge University to do is actually put digital objects into the real world. And as they encounter those objects and interact with those objects, we can actually sync that behavioral data with the brainwave data that we're collecting. So, all of these really cool new neuro devices that are coming out, and like even in the consumer space, like the Muse headset and stuff like that, all this data is really cool. But like, what we really need to do is we need to understand where is that, what's happening when we're collecting that data, like what's going on in that person's, what is that person experiencing? And it's tying the brain data to the behavioral data that really gives us rich insights. And again, I talked a little bit about the AI research that we're doing at McGill, and then we have some other folks at KU Leuven in Belgium that are doing some mental health and well-being and focus research with it as well. These are just a couple of the examples. And so I'm going to bring up my co-founder, Kyla. I'll let her introduce herself, and then we're going to actually throw her into a VR headset, and I'll show you a little demo of all of this.
hopefully not throw me into it, but my name is Kyla. I'm, as Benjamin said, the other co-founder. I'm also the Chief Operating Officer at SilicoLabs. I am also a physical therapist at Mount Sinai Hospital. I have almost 9 years of clinical experience, and I'm also finishing up my PhD in rehabilitation sciences at U of T. And that's me. So let's get into the headset.
Yeah, okay. I think it's okay there. Yeah, okay. We're going to be switching between several screens here, so hopefully this all goes smoothly. So yeah, so basically what this is actually what our software looks like. I think the screen resolution is really big. It's usually much smaller when you're actually developing with. This is called the Unity Game Development Engine. It's actually the most widely used game development engine for indie games and the game development industry. And so when you're leveraging the engine, you still need to know a lot of C# coding to make anything kind of happen in that world. And so what we've done is we've created a custom user interface where people can create these experiments without having any coding background knowledge. So what you do is you create what we call tasks, and so we can actually put interactive objects into the environment, and we can define what the participants, how they can interact with those objects, and we can capture all the data as they're doing that. So I'm actually going to run this task. So this is an ICU training task where Kyla is going to be asked to go and locate some PPE equipment and actually don it. So donning is putting on a PPE, and doffing is the taking off. And there's a very specific set of steps that folks have to do. And this is a program that helps them. So I'm going to actually switch to, here we go. So we can actually see what Kyla is seeing in the headset. Now, you should note it actually has two screens, one for each eye. So we're just seeing Kyla's left eye right now. So I think it looks a little, it's a little tilted, but this is essentially the best we could do, I think. So yeah, she's asked to locate items. So she has to locate and review these posters. And then she's also going to locate some of the PPE equipment as well. So what you're going to see is that as Kyla, we can actually create these dynamics within the environment. So as Kyla gets to one of these posters, you'll see that as she looks at that poster, there's a little circle that loads up, and then you can have this pop up on the screen. And you'll notice, maybe you didn't notice on this one, but the actual UI of the HUD that Kyla's seeing is actually updating as well. So maybe Kyla, can you go to that full one? And yeah, and so you'll see that now becomes colored, and you'll see that the items located has increased. And so all of these dynamics that you're seeing here are actually created by the user without writing any code. So I'm just going to actually quickly switch back to our UI. And for instance, let me see if I can make this a bit bigger. Yeah, so I'm going to try to, so the other really cool thing that you can do with our software here as somebody is actually running it is that we can have them, we can make real-time changes to all of this stuff as they're doing it. So I think that this is just, as you can see, this is a screen that we've created, and we can add any number of these objects. So that box that you're seeing that Kyla's popped up right now is actually just one of these screen objects that we've added, and we can adjust. Let's see, I think, hopefully, maybe I can bring, yeah. So you'll see that as I'm doing this, it's hard to see. I think it's hard to see over. Maybe I should try to move a different one, but I'm actually moving the text around on the screen. So you can actually set up everything in real time. I'm sorry, I think it's a little difficult to see. I think the rendering on this screen is not as good as the other one. But maybe a better example might be on the left poster. So I can click on this left poster object, and we can see that what we've done is we've actually set up what we call gaze interaction zones. And so here, we can actually set up what that gaze interaction, what the range is of that gaze interaction. So I can actually look at the poster, Kyla, if you could look at, or can you stand further away from it? I'm going to try to increase and now can you look at it? Oh, maybe I have to go back. Can you see it now? Yeah, okay. So let me try to go back to our other screen here. So I've actually just increased the distance that Kyla can actually cause that interaction to happen. And I can, do other sort of modifications if I want. I can come over here and change. Oh, can I get back over? No. There it is. Okay. So I could change the color, for instance, of when she's looking at that object, that loading. So let's go back now. And yeah, so you'll see that now the center color is a green color, but it's all completely customizable. We can even come back and we could change the time that it would take Kyla to actually cause that interaction to happen. So I could change it from 2 seconds, and maybe we can change it to 10 seconds. And now Kyla, if you would look at that again, sorry, I'll go back to it. And now you'll see, yep, and now you'll see that it's loading much, much slower. But doing all these kind of complex interactions would take a lot of coding experience. Typically, with our software, you can just add these types of actions, and then you can completely customize the dynamics of those. I'm going to have Kyla go and pick up the mask now. And so as Kyla picks up the mask, you'll see that she can actually put that on her face. And you'll see that, you might not have caught it, but over here on the right, we can actually update Kyla's HUD to show that she's actually put that on. Can you take the mask off, Kyla? Yep, and then so you can see that it's all very dynamic with that. And if we go over to the face shield now, and maybe just hover that face shield close to your face, and you'll see that as she hovers that object close to her face, that she gets a little indication that she can put that on. And if you let go, Kyla, and now she has her face shield on, and you can see that we're actually tracking that data here. So we're actually able to collect not only the behavioral data, but we know exactly when all of those kind of interactions within the environment are happening. So that's really important for researchers. We want to know exactly what's going on in the environment at any given time, and we want to have complete control over those variables. Yeah, so I think that's probably, you could probably stop there, Kyla, but so yeah, that's kind of the overview of our software, and we're just, as the previous talk, which was just mind-blowing to me and super inspirational. I mean, it's so great to see science in video games, and I think in order to have more of that, we really need to have better tools for scientists to be able to create these types of experiences. So the scientists not only can come up with the idea, but can actually create those types of games. So maybe one day we'll see, a researcher or SilicoLabs created game in a Borderlands arcade game. So yeah, thank you very much for your time.
Thank you very much. That is absolutely fascinating. Do we have questions from the audience? I see a question there. Do you want to just turn on your mic?
Hi, I'm Poonam. I'm a student of regulatory affairs, so I wanted to ask you something about that. Like recently, you might know that US passed a law that it's not compulsory to use animals for clinical studies now. So can AI be implemented in those clinical studies to test drugs for, like you said, Alzheimer's? Can it be implemented towards that side to maybe make human looking models or something to test the stimuli that those drugs are inflicting?
Yeah, I think that with this new technology, I think it allows us to capture, we might not be able to implant electrodes into somebody's brain, although Elon Musk is trying to make that happen. But if the level of behavioral data that you can now collect and the advancements in even just external EEG devices, I think is giving us a lot more insight. So now those animal models that we were using to capture that data, they are less appealing, and we can actually start doing that research. We can stop relying on those animals as much. And it's funny because I talked about that study where we tried to emulate with the mice, and what we found was that we had very, very strong effects with the mice. But as we got to humans to do the exact same task in in a virtual replica of the space, not at all related to the rodent data. So, we're kind of taking these animal models and saying, this is how it works because we have similar brains. But I think as we start being able to directly compare these two species behaviorally, that you know, that's also probably going to you're going to see a sway away from that, and definitely with AI being able to replicate those types of models. Yeah.
Other questions? I have a question around, you know, I could see, so early days still for the two of you, I think, right? Yeah. So how have you found that process of trying to merge these things, of launching a company? I mean, I was sitting there thinking, okay, I have 1, 2 things to do today. You guys are like doing a degree and clinical and a company. And so, but how have you found that process, in Toronto, but you're also connected to Quebec. And so can you speak a little bit about the environment for AI that you've seen in Quebec versus Toronto, and is there a difference there, or maybe I can...
Yeah, for sure. I'll just say there's been a lot of coffee at our house, so we're highly fueled by caffeine. I think it's been a really interesting journey. I mean, really, I'm a clinician originally. Now I'm a scientist, and now I'm an entrepreneur, and that's definitely been a journey. Lots of learnings. We've been really well supported by some local accelerators. So we're part of UTest, also supported by Mars Venture Services, the Health Innovation Hub, Creative Destruction Lab, and the Mila Entrepreneurship Lab, which is part of the Quebec AI Hub. And so I think the support and mentorship has been really great, but I think we still have a lot to learn. And so definitely looking to make more connections here today. I'll pass it over to Benjamin in terms of the AI piece, because he'll have more to speak to that.
Yeah, so yeah, kind of highlighted the bright spots. I think it's also been, you know, some of the experiences trying to be an entrepreneur in the world of science. You know, it's been difficult actually. It's difficult when with science, it's kind of like a publish or perish kind of mentality. And so I actually, when I was, you know, originally creating this software, I published an open source package, and there was no propensity for me to keep doing that type of development. I had published on that open source package. I was really, you know, passionate about creating better tools, but in the world of science, there's no incentive to do that. And so when there's no incentive to do that, you don't get a lot of encouragement for doing stuff like that, especially when you, you know, you're committed to a professor who wants to publish a lot and their careers rely on that. So I think there's been, there's things in science and at the intersection of science and entrepreneurship that I think really need to improve. And I think that as we get off the ground and we've gone through that experience, it's something that, you know, both Kyle and I are very passionate about, trying to figure out ways of making that more, streamlining that process from lab to market. And Kyle always shares an interesting statistic, which is about 17 years to get research to, you know, the market. And that's because there's this huge divide between basic research and people who actually want to create that thing. And I think it's actually, yeah, continued by some of the systems in science. Sorry, that was my kind of rant about science and entrepreneurship. Lots to say about that. But as far as the AI community, we're plugged into the Mila Entrepreneurship Lab, which is kind of, you know, the Vector Institute here in Toronto, and it has 3 different AI hubs where Amy is at Alberta, we have the Vector Institute here, and then Mila is in Quebec. And it was kind of a happenstance that I was working with a professor here at U of T who actually transferred and became faculty at Mila. So that's how we kind of got plugged in there. And we actually haven't made a lot of inroads in the AI space here in Toronto. We actually haven't tried too hard because we have so much going on, but there's any folks in the room that are interested in those types of collaborations, we're always open to doing that, to learning more about the AI systems elsewhere. Yeah.
Thank you for that. And it's not a rant. It's important for us to understand if we want to grow the industry, and not just the industry of scientific, the benefits in Ontario and across Canada. We need to understand that. And interestingly, some of the things you've said are the same things I was saying when I was doing my doctorate, and we won't talk about how long ago that was. So I do appreciate that. So thank you very, very much for that. I think we'll just, I've got a couple of announcements to make before we finish, and then Carla and Ben are still here, and please stay for some networking and talk to them about their headsets.
Come and try out the devices if you like as well.
Yeah, so you can, sorry for those people online, but for the people here, you can have a little try of the devices as well, so that might be quite fun. So I just wanted to talk about a couple of upcoming events. We have a breakfast series on rare disease coming up on February 16th. For those that don't know, it's one of those weird statistics that 1 in 12 Canadians have a rare disease. So you think, well, that's not very rare. Well, they're all rare, but cumulatively. So it's something that we really need to take a handle on. And so that will be our breakfast series coming up. And then on February 22nd, we also have an industry academic partnership from U of T at the downtown campus here, a discussion on why they're so important and how you can leverage them for success, and potentially how you can take what we've learned both from Ben and Kyla here and what we heard from Gearbox and McGill and MMOS, and how did those things happen? I know MMOS because I helped them with a specific industry academic partnership and Gearbox, and so I'm a big fan of those kinds of things. I do want to remind you that we have our annual awards presentation coming up May 17th. It's down always at the Liberty Grand. It's a great event, a lot of networking. It's in May now, so there is no boots needed, hopefully. There's no big coats. You know, we hope not for a snowstorm as we used to have every year. But registration's coming soon. There's a phenomenal group of award winners this year, as always. So please save the date and come along to that event. Finally, I'd like to thank all of our corporate sponsors. I won't speak to them all here, but you can see them up on the screen. We really appreciate all of them. Our gold sponsors, our silver sponsors. I would like specifically to thank Danny and RSM for hosting us here today. We really do appreciate that. And I just want to make, the comment that Life Science Ontario is a member-driven organization. We're here for you. We're here to develop things for you, to advocate for you, to help build a life science strategy in Ontario that will put us ahead of the world. And so please engage with us. Please talk to us. For the breakfast meetings, as we call them, if you've got great ideas, let us know. We're always interested to hear from you. And having said that, I'm going to thank all the people online. Thank everybody here today. Grab a coffee, have a chat, talk to people. It's really been a great day and really exciting. And line up, I think, is what's going to happen here to try the headsets. So thank you very much, everybody.